In today's webinar, Irene will describe and demonstrate key aspects of SHACL. Before we get started, we'll review that agenda in just 1 second, but before we do, please feel free to ask questions as we go along by using your GoToWebinar controls. To post questions, please look on the right-hand side control panel. You should see a drop-down box for questions. If you click on the box, you should be able to post your question at any time during today's presentation. We will address as many questions as time allows at the conclusion of the webinar. We will also be recording today's webinar and we'll send a link to the recorded version as well. Okay, as you can see on your screen, here's a brief overview of how today's presentation will flow. You will see that we'll be doing a quick introduction of SHACL, what it is, and a brief history. Then Irene's going to do a demo of creating and using SHACL Shapes. We'll take a little bit of a deeper dive and show additional features. We will not cover SHACL and OWL as well as SHACL and SPIN in today's webinar. We have covered that in the previous webinar, and we will have slides on that as well that will be shared after today's presentation. Irene will spend some time on SHACL SPARQL and SHACL rules, and then we'll have some time for Q&A at the end. So if it's okay, we would like to kick off today's webinar with a brief polling question. This will give us a better understanding of your knowledge and will help to guide today's discussion. So just a quick poll. If you look on your screen, you should see, are you familiar with these technologies or standards? And please check all that apply. RDF, OWL, SPARQL, SPIN, or none. I'll just give a couple of seconds for those to finish. Okay, I'll close the poll and share those results. Okay, it looks like most of you are familiar with RDF, OWL, SPARQL, limited on SPIN, and a few of you aren't familiar with any of those. Okay, thank you for taking the time to do that, and we'll go ahead and pass it over to Irene to get us started.
Presentation, as Christy mentioned, will be about introducing SHACL. This is the second webinar that we are running on this topic, and the program is somewhat different from the first program, as Christy has already explained. I'll be going a little bit into SHACL SPARQL, and you'll know in a moment what it is, and into SHACL rules. So if you have not attended the first webinar, it may still be worthwhile to hear some aspects of it, and we have recording available. But you know, to some extent, the content covered in the agenda overlap quite a bit, especially in the beginning. So what is SHACL? First, SHACL stands for Shapes and Constraints Language, and it's a new standard from W3C, World Wide Web Consortium. It just became a standard at the end of June of 2017. And essentially, it's a schema language for RDF. And RDF, for this 15% of people who are new to this space, is a graph data model. It's the way to a standard for storing information as a graph of connected nodes and links. And RDF is also a W3C standard and has been around for many years, and all the other languages built on top of it in the stack, and there are quite a number of RDF databases, graph stores that support it. So one of the basic things about SHACL in terms of describing it, we differentiate between a graph with shapes, and it's called a shapes graph, and then a graph with data which is validated against those shapes. These are just roles. Any graph can be called a data graph, including a graph that actually contains shapes, and you could use the same graph to be both a data graph and a shapes graph. So this is just roles that tell the processor, tell the SHACL processor what to do. So why SHACL? I was a co-chair of the W3C working group that produced SHACL, and the work has started about 3 years ago. And the main motivation for the work was that, well, RDF has been available for a long time, but until SHACL, there has been no schema language for RDF. And you've got your data, you want to be able to define schema for it, of course. So for that reason, there was a need for that in the field. And various organizations and users have been coming up with their own proposals and ways of doing that, ways of specifying schema for RDF data. We at TopQuadrant defined something called SPIN, SPARQL inferencing notation, and that was submitted as a proposal to W3C. IBM has defined something called resource shapes, also submitted it as a proposal. And there is a community around shape expression language. And in general, various vendors and various end user organizations using RDF have also created their own ways of doing that. So there was a need for a standard, and thus the working group was chartered. Some of you may say, well, but wait, isn't there a schema language for RDF? RDFS stands for RDF language, schema language, and then there's OWL. No, those are not schema languages in the traditional sense. I'm not going to go in depth why, because those of you who are using OWL for quite some time, and a large number of people are familiar with OWL, probably already know why. And those who are new, it may be irrelevant, but if you want to hear in detail why those languages are not suitable as a schema languages, in the previous webinar, I went through this slide in more detail. So what we are hearing folks who have started to use SHACL say is that SHACL is actually all done right, and this is an interesting image that was tweeted a week or 2 weeks ago, and I thought just share it for fun. So with that, so what does SHACL do? Well, the primary goal of SHACL is that it ensures that RDF data conform to a defined schema, and that's its primary goal. For example, and this is an example of how you would run SHACL validation using tab rate. You've got a request to validate data, and the data graph is specified. You could see here it's being specified, and then the schema, and then the shapes graph is specified, and then you could request your output report to be in whatever format you want it to be. By the way, the validation report is also defined in RDF. And then you run your validation and you get your validation result. So that's kind of a quick example of what you should expect to receive when you validating data against SHACL shapes. However, SHACL could also be used for other purposes. We hear a lot of interest in rule-based inferencing, and SHACL includes not just data validation, but also rules. And I'll talk a bit about it towards the end of the webinar. And you could also use SHACL to specify interfaces. This could be user interfaces, but it could be just communicate data structures and things of that nature. So there is a variety of use cases beyond data validation. As I mentioned, there have been already when the working group has started, there were already a number of submissions that we started with. So those were core, inputs to SHACL. And they played their role in influencing SHACL design. Overall architecture and the extension mechanism was inspired by SPIN from TopQuadrant, but SPIN had the architecture and a way to create your own constraints and rules. SPIN never had a standard pre-built vocabulary for some specific constraints and rules, like cardinalities, like data types, or whatever else the majority of users of the schema language may want to say. IBM, on the other hand, had preset vocabulary for those commonly necessary, commonly desired constraints. And SHACL core is based to a large extent on that vocabulary from IBM resource shapes. And of course, during the course of the working group, we've collected use cases and we further extended the core vocabulary to support as many use cases as we could. So SHACL is expressed in RDF, but there was some interest in having a compact text-based syntax, more compact than RDF. And that was produced as well, although it didn't go all the way to being standardized. And that was inspired by the SHACL Shapes expression. A rule part of SHACL is mostly inspired by SPIN. So here's a quick visual of what a shape looks like. Key components of the shape are targets. Targets specify which data should be validated against a given shape. So a shape says my target is this kind of a data. And then constraints, which actually specify the conditions that data has to meet in order to be valid against that shape. And then there are rules. So we're going to cover all three of this in this webinar. Let me give you a first example of how a shape looks like in its RDF serialization. So here, walking you through that, we have a shape. Now there are two types of shapes, node shapes and property shapes, and I'll talk about it in a moment, but for a time being, there is a shape called person shape. Its target is any instance of the class person. So all resources that are of type person will be validated against this shape. Then we say that all these resources, their URIs have to follow this defined pattern. So they have to start with http mydomain.com/person. So that's part of the node shape itself, constraints on whatever resources will be validated against it. And then it includes two property shapes. The first one says that the values of the first name property must be a string, and you have to have at least one of them. And the value of the last name property, you have to have at least one. You cannot have more than one. It has to be a string, and that string cannot be longer than 20. So here you're seeing this SHACL core vocabulary, this min count, max count, data type, max length. All of this is defined in SHACL core as a ready-to-use vocabulary. The property shapes define constraints on the values of certain properties. So here we see it in more detail. You could see this is a node shape itself, and then there is a property shape. Now, the property shape can be folded into the node shape, just as we are seeing here and we saw previously. Essentially, it's a blank node for those of you familiar with RDF. Or property shape could be specified separately in this standalone fashion as its own named resource, and then we're just referring to it using sh property predicate. So that's another variant. It's exactly the same as this one. The meaning of it exactly the same, but the syntax uses one kind of embedded property shape and one standalone property shape. When you create your shapes, it's recommended that you type them. In other words, that you say explicitly, oh, this is a node shape. But it's not required. SHACL processors must be able to recognize shapes even without those type statements. So the node shapes, the role of the node shapes is then to specify constraints on the targets directly. Role of the property shapes, specify constraints on the property values of the target resources. And then the node shapes are also used to group property shapes together. So you could specify them, include them into the node shape. Here's the same picture that I showed earlier, but now expanded to give you the full scope of SHACL and you know, a much richer picture of it. So in terms of the target statements, there are pre-built core targets, and then you could use SPARQL or JavaScript to customize your targets. In terms of the vocabulary itself, this is things like data type, like min count, max length, etc. All of them are called constraint components, and you could build up your own vocabulary of constraint components in addition to the core constraint components. And then rules have, you know, also can be defined in SPARQL, can be defined in JavaScript, and etc. So things that you see in a dark blue, these are so-called advanced features of SHACL, and they have been published as a working group note. In other words, they didn't go through the entire standardization process, which at W3C is quite extensive. You have to publish the spec, go through several drafts, have issues submitted and resolve those issues, then have last calls, and again have issues submitted and resolved. So it's a fairly lengthy process. And the working group, during its course of life, which was about 2.5 years, it was chartered for 2.5 years, we basically ran out of time. We couldn't take all the advanced features through this entire process. And when that happens, what you do is publish it as a working group note, which what we did. And now that the working group concluded its deliverables for SHACL 1.0, there is a community group and a time to mature and use the standard. And then a new working group can be chartered to take, you know, to finalize and take it remaining pieces through the full standardization process, hopefully in much quicker period of time, because the issues have been ironed out and resolved in its use. So that's kind of a new part of W3C process, have things mature in community groups. And there is a community group for SHACL, and unlike working groups, which are open to only W3C members, anyone could join a community group and participate in it, and I'll invite you to do so. So with that, quick introduction, let me show you how you actually go about creating and using SHACL shapes. I'm gonna use, for the demo, I'm gonna use Top Edge, which is an enterprise data governance product from TopQuadrant. And it used to manage different types of collections of assets, like data assets, business glossaries, technical assets, which is information about your applications. Data assets would be information about databases, etc. Ontologies are also type of asset collections that are managed by Top Edge. Furthermore, all the other models are based on the ontologies. So here you see that I have a number of ontologies already pre-created, but for this demo, I'm gonna create a new one and go over the example that you've seen in the slides. So I'm gonna create a new ontology, and I'm gonna call it SHACL demo. Going to create that. All right. And I am going to go and start working on my definitions and shapes. So let me create a class person. Okay. And let me create two properties that we have been talking about, which is first name and last name. Now, at this moment, Top Edge supports, RDF, SPARQL, as well as SHACL. So you see that, I could use some pre-built things that actually have to do with RDF and SPARQL, but I'm not going to use that. I'm going to just focus on SHACL right now. In targets, in SHACL targets, I could target instances of a class, or I could associate property shapes directly with the class itself, and that's called an implicit target. So when a property shape is associated with a class, then class becomes a node shape, and the target is implicit. I don't have to explicitly target it. So I'm going to create a shape for the first name by clicking on this button, and I'm constraining property first name. And here I am seeing all the pre-built vocabulary, so-called SHACL core, that I could use. So we said that there must be at least one first name. That's the min count constraint. We also said that the data type must be a string, and I'm gonna do it right here. All right, and that's all I'm gonna do at the moment. I'm gonna save my changes. I'm gonna do the same thing with the last name. Constrain the last name property. And I am going to say that its min count is 1, max count is 1, because remember we didn't want it to have more than one last name. I'm going to say that's also a string here. And I am going to say something about its length, 20. So you could see that there's actually many more things for us to say. All of this is part of the core vocabulary. And yeah, so there's, for example, you could say min inclusive and max inclusive. Like if I was dealing with integers, I could say from 1 to 20 or something like that. And there is some complex constraints that involve us doing logical expressions as well. So, but for now, let me save this, and I am done with my constraints. What happened as a result, if I click on a class person, I see that the constraints are there. Yeah. And it will now be treating it as a node shape. So to try what happens, let me now create an instance of the person. So let me create myself. All right. So now you see that, and this goes now not to validation yet, but to user interface generation. So we're seeing that for the person, there is a first name and it's required because the min count is 1, and then there is a last name and it's indicated as being required. So the form was generated by this shape specification that I have just done. Let me just save it as is. And now I could go and run my data validation report. So you could see that at this point I have 2 errors. There is no first name and there's no last name. So that's an error that I have. Let me go back and edit that data a little bit more. So see Irene here, and I'm gonna go into the edit mode and give myself a first name, and I'm gonna give myself a last name that is gonna be long. I don't know. Short. Okay, so now I'm gonna try to save. And I see the real-time validation kicks in on edit. So you see here that it's now the problem is the previous problems disappeared because the both last name and the first name exist, but the last name is too long, and we have an option, a suggestion of what can we do to fix this problem, which is the delete it or prune the string to be only 20 characters. All right, so this is a quick example of creating shapes and doing shape validation, data validation against the shape in Top Right Edge. I'm going to go back to my slides, but I will actually continue with my demo as I go through more examples, but I want to introduce you first to some additional things that are possible with SHACL. So let me go back to my slides. This is a slide that Christy referred to. I'm not going to talk to that, but you could take a look at it. It will be in the handouts, and there's a detailed blog on differences between SHACL and OWL. here's an additional example. So far we've talked about the target being instances of a certain class. SHACL has some pre-built targets. Membership of a class is one target. Then there are 3 more pre-built targets: subjects of, objects of, and target as a resource. So you could say that the target of a shape are all resources that have some value for the predicate Social Security number. In other words, all subjects of a triple where Social Security number is a predicate, irrespective of what their type may be. And that's just as valid shape as what I showed before. It just uses a different target. Similarly, you could use the objects of. So this would be then if I changed it from target subject of to target objects of, then what I'd be targeting are actually the values of the Social Security number. Then I could say that the Social Security numbers have to be a certain length, they have to be only numeric and things like that. I would not be defining information about people, essentially, or whomever has Social Security number. I would be focusing on the Social Security numbers themselves. All right, another example is how we could use logical combined constraints. So there is ability to say or, ability to say not, ability to do qualified cardinalities. Those of you who know all know about qualified cardinalities. You could do that with SHACL as well. And here is an example. What this shape says is that, well, if you have a Social Security number, not only you must have a first name and a last name, but your type must be either a customer or a person. So your RDF type statement must be either a customer or a person. So let's see some examples of that. Let me go back to my demo. And now I'm going to show you a fairly complex or fairly rich set of shapes. As I mentioned, in Edge, everything is based on models that are defined using shapes. And here you could take a look at the ontology that defines how glossaries and glossary terms should look like. Okay, and actually, let's see, glossary term. So it has a number of shapes associated with it, and you could see them here. Let me maybe open it in a separate window so you could see that better. Yeah. All right. So you could see, for example, that there is a constraint on a property acronym. And here we're using OR expression because we want to say that it could either be a string or it could be something called language string. In other words, it could be a string with a language tag associated with it. So you see several of this kind of more complex definitions here with an OR. And you also see some new things, which is the kind of section, or that's how that's part of the support of SHACL for the UI generation. When you specify a constraint, you could say what section of the form it can belong to, and you use the group property for that. And then you could specify an order within that group. So you see some examples of that here. So this is a set of constraints for the glossary terms. And some of them are also come from the parent classes. So you could specify constraints at various levels of the class hierarchy, and they get inherited. So let me go back here. And if I click on this particular constraint, you see how it's defined using an OR. Okay, let me go back to my presentation. Similarly, I'm going to skip the slides about comparing SHACL with Spin, and you could go to the slides. You could go to blog that referred here, pretty extensive. So here are some additional features. You could, in addition to specifying what properties are allowed, you could also say that besides what you've entered in a shape, no other properties can be present. So that's used. That is done using close true, which means that if you specify first name and last name, this is it. Nothing else. You could not say, country of birth. You could not say works for. You could not say anything else. That's what the close true is used for. In conjunction with that, you could also use ignored properties. So this means that no other properties except what I'm listing as ignored. So RDF type would also be allowed, although there is no property shape. We don't know what values it must have, but it passes. So if you have not mentioned something explicitly in property shapes, you could put them in ignored properties and they'll still be allowed, but nothing else. Okay. So another feature that I don't know, that maybe have example of it later, but see, no, I don't. Is ability to deactivate the shape. So let me show this on my example. And this is important for reuse. Let's say you've got this model that tells you what glossary term should look like, and you look at it and you say, well, that's pretty good. I want my glossary terms to look like that, or I want my per data about people look like that, but there's one or two things that I want to change or I disagree with. So if there is a constraint that you don't like, you don't want to accept and reuse, you could deactivate it. And the way to do that, there is a convenient flag where you say, yes, this is deactivated. And once you deactivated it, this will no longer apply. So that's very useful when you want to reuse shapes and models developed by someone else, and there is some delta. There is always some delta that you, for whatever reason, don't want to reuse. During the last webinar, we also were asked a question as, okay, so what you're showing at the demo is very class-centric. What if I just want to work with shapes and I don't want to use classes? It is class-centric because majority of the models out there already define some classes, be it RDFS classes or be it OWL classes, and we want users to be able to associate shapes with them and organize them and build built on those models. But if you want to leave all of this aside, you could work just with shapes. So let's take a look at our SHACL demo. What I'm going to do now, I'm going to change. So here you see right now that the root of this class hierarchy tree is all thing, and I have subclasses, and this is what I defined the shapes for. Now I'm going to change that to be, I could make the root of it to be RDF as resource, and then you see a lot of complex things. Or I could make a root of it to be a shape, right? So I'm gonna go back, and now all I see is a class shape, and then subclass node shape and property shape. And there is a number of pre-built node shapes already, and I could create my own node shape. So do example. Node shape, and you could see a form for it. So now you see some pre-built targets. So I could target a class, I could target objects, I could target subjects, and so on. So I'm not going to do much with it. Instead, I am going to take a look at how you could, in addition to this pre-built vocabulary of cardinalities, lengths, and other very common constraints, how you could use SPARQL. So here's an example of the constraint that is actually using SPARQL, which says that each class must have a parent class. And here you just see, a short description of it. You don't see the actual SPARQL because this is, if you go into that level of technical depth, you should be using TopQuadrant Composer, which is an IDE that we provide, and not using TopQuadrant Edge. So let me, I could switch to TopQuadrant Composer to show you that. Or, maybe even better, I could just go to slides and show you that in slides. So this is how a SPARQL-based constraint looks like. Instead of using pre-built vocabulary, you could just define a SPARQL query that constrains it in any which way you want it to be constrained. So this SPARQL query basically says, well, if you have a class and the targets of it are classes, then there must be a statement that is a subclass of something. We're excluding some things from it, like RDF as resource is not should not be deemed invalid, etc. But that's we could use anything in SPARQL to define our constraints. And another feature is this suggestion generation. You saw it in play where the tool suggested for me to trim the last name. How does that work? Well, that also works with SPARQL. So you could have a couple of suggestions here. For example, make it a subclass of all thing. And that's your fix up rule, which is an update query that if a user accepts the suggestion, then it will insert this statement. Or you could make it a subclass of RDFS resource. That's the second suggestion. So that's how you could extend SHACL with your own SPARQL statements. What you also see here is an example of the validation report vocabulary. You see a message, and you see, I think, a couple of other things. So validation reports in SHACL are defined as part of the standard. It's a pretty rich vocabulary that you could use. Now I'm going to go quickly talk about user-defined constraint components. So instead of just using SPARQL query, you could template them and extend the vocabulary that way. One example of it is something that we have pre-built, a primary key constraint component, and it's defined as so. Again, interpret composer. To define those, you create an instance of constraint component, you give it a message, you give it a parameter, and you specify a SPARQL query, SPARQL validation query behind it. So that's your definition. And now that you've defined it, then it's available as a vocabulary, just like a min count, max count, etc. were available. So rules. Lots of interest in SHACL rules. There are two types of rules. Triple rules specify inferred statement as a subject predicate object triple, and then SPARQL rules specify the inferred statement as a SPARQL construct query. Here's an example of the triple rule. The rules in SHACL have two parts. The inferred statement, and here it's specified as a triple. So, and then the condition you see below. So what this rule says is that if you have a rectangle and if its width is equal to its height, then you could infer that it is a square. So you could infer a triple that this is of type square. That's pretty much all there is to triple rules. And the rules in general. It's essentially exactly what you expect from rules. It's a condition and then the result. I think we are, running out of time, so I'm not gonna explain the compact syntax, but it exists. And instead, I'm gonna go to Christy for questions. She told me that there's quite a number of them.
Yep. Thank you, Irene. And if you haven't already done so, please go ahead and submit your questions and discussion points in the question box located on the right-hand side control panel. I do see that we have several already, so let's go ahead and start. Maybe we can take this one as the first question. Irene, is it possible to generate shapes?
Yes, very good question. So yes, it is possible to generate shapes, and actually in a number of ways. For example, in TopQuadrant, there's a feature where it will take your data, and based on the data, it will create suggested shapes. And this could be, some of it is fairly simple, which is, okay, we're gonna look at all the values of certain properties and see if the data type is always a string, then we're going to suggest that. The data type is integer, we're going to suggest that. If there is, if it's always present, then we're going to say, well, its mean cardinality is 1. So that's, fairly deterministic rules. Could also use machine learning to try to learn more complex relationships in, data constraints, if you would, in data, and specify even more, sophisticated conditions, etc. So that's one way to generate shapes. Of course, if you already have a model in some kind of a structured way, then shapes could be generated from that. There is a pre-built feature to generate SHACL shapes from OWL. It covers probably, 80–90% of what people typically do with OWL. Not everything, because OWL is a rich language in itself, and there is a variety of ways people use that, but a pretty good starting point. We used fiber, and I think it's covered 90% of that. maybe even more. And if you have XML schema or UML or anything else, then of course, or spreadsheet, then of course you could generate shapes out of that.
Okay, great. Thank you, Irene. Another question. Here's a good one. The blank node approach seems to be more flexible than the separate property approach. The latter forces the property to be used the same way each time. Can you comment on that, Irene?
So the problem with the blank node approach is that, blank nodes are just that. They are blank nodes. They are not, they are not directly referenceable. There's, there is no identity for them. It doesn't, using explicitly named resources, URIs for the property shapes doesn't really force you to do anything other than it gives them the identity. You don't have to use them every time. You could have multiple different property shapes defined, and let's say on a property. So you could have for the property first name, for example, I could have property shape 1 first name, property shape 2 first name, property shape 3 first name, and then in one node shape I use property shape 1 for first name, and another one I use property shape 2 first name. So I don't think there is any limitations in using URIs.
Okay. Maybe one or two more questions. The next question we'll take: does the SHACL vocabulary support validating joint uniqueness constraints? For example, the combination of, say, 3 property values is unique.
Yeah, another good question. Basically, this is why we have a way to extend SHACL core with your own constraint components or SHACL SPARQL. And your own constraint components would be based on SHACL SPARQL, because obviously a working group at W3C cannot think about all the possible use cases and all the possible constraints and rules that people may want to express in their own domain of interest. We have pre-built in the core vocabulary the way to compare 2 properties. We have not pre-built in the core vocabulary the way to compare 3 properties or 4 properties or 25 properties for that matter, or the fact that the combination of these 2 properties in a certain order and concatenation or whatever else has to be, the same as a, combination of some other properties, etc. But you could either use SHACL SPARQL, or if you think it's going to be reused a lot, you could define the constraint component, specify the parameters. The parameters in this case would be the 3 properties. So you're going to have 3 parameters: property 1, property 2, property 3, and then use that and publish that for use by the who may need this kind of constraint and that constraints, and that's the beauty of SHACL as well, that as you extend the vocabulary, it could be used by others, so they could benefit from your work. They don't have to repeat it.
I think we'll have time for one more question. So let's take this. Could you describe the status of the SHACL API work going on? How mature is the API at this point?
By SHACL API, I am just, I think probably I will take that question directly with the person who has asked it, because I'm not quite sure what is meant. Is it meant by something that, is it meant by a tool, or like, because we offer support for SHACL Integrate products, but we also have some open source library that's out there. So I think maybe that's what the question is about, as opposed to a standard. So I'll iterate with the person who asked it in order to clarify what they meant.
And we will be answering all the questions that we received today as a follow-up. I think probably at this point we can go ahead and end the webinar. We're right up against the hour, so let's go ahead and wrap up today's presentation, and we will be providing those answers to you in the form of an email response to all the attendees, as well as providing a link to today's recorded presentation. We hope you found today's information valuable, and thank you for everyone's attention and interest, and have a great day. Thank you.